We decided to do our project on the Helotes Creek. Located in the Upper Leon Creek watershed, the Helotes Creek runs from the city of Gray Forest through the city of Helotes, as it proceeds to merge with Calabre Creek in San Antonio. Running for nearly 8 miles, the creek has been above the normal level based on the last record of data. The Helotes Creek has many different unique geographical features. The Helotes Creek floods many times throughout the year, which causes erosion and deposition along its banks. Because of flooding in 1940, the city of Gray Forest even installed a man-made dam that created a natural swimming pool for their community. In the Google Earth image, you can see exactly where we walked along the Helotes Creek to take pictures and videos of it. Also, we included an image of the streams map, which shows how far it runs from start to finish. As our book said, every stream and body of water has a surrounding area of ground that contributes runoff to a stream. These surrounding areas are classified as watersheds. Every drop of water in this area contributes to our stream. Bexar County consists of 17 different watersheds. Helotes Creek is located in the Upper Leon Creek watershed, which stretches from the city of Gray Forest to the city of Leon Valley. The Leon Creek watershed is also located in the recharge zone for the Edwards Aquifer.
Also, as the stream runs downhill, like I said before, rocks are being transported as well as branches and different minerals. The minerals would eventually be released and deposited either on the side of the stream or in the more shallow areas. Once the rocks and branches find new spots to stay, it will eventually change the flow of the stream current and will affect the speed of the creek. Usually streams don't travel in a straight line. A large tree, large rock, or fallen log can alter the stream speed and create bends or arcs around certain objects. In this creek, water is flowing at a downward direction. This is because of the gravitational pull Earth has on streams to move them to the center of the Earth. As you can see, the Helotes Creek is trying to move to a lower elevation. As it's moving downhill, the stream is collecting all of the rocks and minerals downstream, breaking down rocks into smaller pieces. This will then lead to different weathering agents like plants growing from the minerals left behind.
In the video, you can see how high the water level can rise during a flood. As the creek floods, it deposits sediments from the channel to the low-lying land adjacent to the creek. After each flood, the floodplain will rise, but the elevation of the floodplain will never be as high as the maximum flood level. In the video, you can see that there are man-made dams to help control flood levels.
In this video, the Helotes Creek flooded back in 2015. Erosion was a key component in this flood because water levels were higher than they normally would be. With erosion coming into play, this will then have led to rocks being broken down to smaller pieces, carrying minerals down the stream and depositing some behind for plants to grow in the future. In conclusion, the Helotes Creek was a good example of many geographical elements that we studied in our physical geography class. Before, we would just look at a creek and would just think of it as it was, a creek. With this knowledge we learned from class in our textbook, we can now look at them from a more geographical standpoint.